sir, now there are 53 participants. Shall I
Yes,
admit them, sir?
Yeah, yeah.
Disconnect.
Good morning, everyone. We are just waiting for a few more participants to join. So we'll start in another 1 minute, 1 or 2 minutes. Okay. Good morning, everyone, and I welcome you all on behalf of Department of Management Studies, the Anand Sagar College of Engineering, for this MDP on multivariate analysis and research. And since this is going to be for 3 days, what I did feel is I should be able to go through this subject. Okay, request you all to mute, and if there are any questions, please let me know. Okay, no problem at all. Now, when we talk about multivariate analysis, specifically in terms of research, what we are mainly looking at is gone are the days when we used to take just one variable at a time and then go ahead with all these analysis, everything else. But now there is plenty of data which is available. People are talking about artificial intelligence. People are talking about data analytics, everything else. And you will be able to find that you have both structured data also, you have got unstructured data also. Now, if you have unstructured data, you will be able to understand that there are a lot of softwares which are available. And these softwares which are there are such as R, you have got Python, which are used to the maximum extent. They are open source softwares also, and they help in not only in terms of collection of real-time data, but also converting this real-time data, which is unstructured, into a structured format. So when I refer to structured format, it means that we are capturing the data in rows as well as in terms of columns, and then we are going for analysis. Now, as what I wanted to start with is, I just wanted to start with this quote by Tom Peters, which is always talks about in terms of chaos theory. Okay, so whenever we talk about chaos, we refer to this as the unstructured data. So most of the time, we have got unstructured data, and what we are trying to do is we are trying to look at this chaos, and we are trying to say, when we understand in terms of this chaos theory, we are just saying that, is there any possibility that when I have these unstructured data, plenty of data with me, can I use this data and then arrive at some decision making? So all we are trying to do at the during this MDP is to concentrate mainly on coming to decisions, and I believe that majority of the scholars who have registered today are mainly looking at using the knowledge on multivariate analytics in their research as well as in their PhD research. And there are a lot of students also who are present today, wherein they are looking at how can we apply these concepts which we will be learning specifically with respect to multivariate analysis in their projects. So what at the end of the day, when I'm talking about, or when we have structured this entire workshop, the main analysis that, or main concentration that we will be concentrate, or main concentration will be towards, you have got plenty of data. How can you actually reduce this data to maximum extent so that with the available information that you have got, you will be able to reach the best possible consensus. So if this is the case, what I would like to, or how would I like to go about is, since the entire MDP is for 3 days, and we this multivariate analytic techniques in research is a 2-semester course, or in terms of a 3-semester course. But ultimately, what is very, very important is what are these various techniques are, in what way these techniques are used, and what is their usage currently in research. So what I would like to do today is, I would like to concentrate mainly into what these multivariate analytic techniques are, what are the variations which are there. So I would like to concentrate today on univariate analysis techniques, bivariate analytic techniques. We will go through various forms of ANOVA, or in terms of MANOVA, ANCOVA, everything else. We will try to go through it today. Tomorrow we will go through in terms of the regression based techniques which are there. Within regression based techniques, we have mainly, I will be concentrating upon regression as well as the classification based techniques also. And on the third day, we can concentrate on how the decisions can be taken based upon various techniques, such as interdependence techniques, such as factor analysis, cluster analysis, and all those other. So when we mainly talk about in terms of multivariate analysis techniques which are there, you will be able to notice that these multivariate analysis techniques are why there is a necessity for us to go for these multivariate analytic techniques, is for the reason that whenever we go for statistical techniques and whenever we want to prove any hypothesis, we are mainly concentrating mainly on studying one variable at a time, or 2 variables at a time. But what if I am trying to understand a concept, I'm trying to understand an abstract, wherein this concept, in order for me to understand this concept, I need to capture several variables. So there are several measurements which are taken on a single variable or multiple variables. And if I'm trying to analyze all these variables at once, we will be talking about mainly in terms of multivariate analysis techniques. So when we mainly looked at multivariate analytic techniques, why there is a necessity for multivariate analytic techniques, when we understand that these are just in terms of the extensions of the univariate analysis as well as in terms of the bivariate analytic techniques. So when I talk about the univariate analytic techniques, we will try to go in depth with respect to these methods which are there. And what I will try to do is, majority of the time in research, we gone are the days when we used to use only Excel or in terms of SPSS. Now what we are trying to do is we are trying to move towards R, we are trying to move towards Python, wherein you just write in terms of few lines of code and you will be able to get the results. But what is very important is how will you be able to interpret the data, and which all variables will you be able to consider when you have collected responses on a questionnaire, on a structured questionnaire, and it has got so many variables. How will you be able to capture the right variables for your analysis? So multivariate analytic techniques is nothing but it is just an extension of univariate analysis as well as the bivariate analysis. So instead of me doing univariate analysis 100 times, instead of me doing bivariate analysis 100 times, all I am trying to do is I am trying to come up with various methods which will be able to help me reduce the amount of method or in terms of the techniques or in terms of the repetitions that I will be able to do using in terms of univariate as well as bivariate analysis. And thus, when we talk about regression or in terms of ANOVA, you will be able to notice that in regression, all we are mainly talking about, we have that I think so. There is a question, will we get the recordings? I think so that will be told to you at the end. So when we talk about in terms of the regression also, instead of me doing a regression wherein you have got, you are mainly looking at a dependency technique, okay, wherein you have got a dependent variable, you have got an independent variable, and what we are going for in terms of multiple regression is wherein you have got more than one independent variable and you are trying to analyze this relationship. But my question is, what if I have got more than two dependent variables? What if I have got more than two independent variables where they need not be continuous in nature, they might be discrete in nature. Some might be quantitative in nature, some might be qualitative in nature. So if that is the case, how will we be able to address this issue? Second one is when we look at in terms of ANOVA, we will be doing a lot of methods, everything else. When we look at in terms of ANOVA also, when you have a dependent variable which is metric in nature, and you have got independent variable which is categorical in nature with more than 3 levels, which we always refer to as a factor. What if I have got more than 2 dependent variables? What if I have got more, if I want to understand the relationship between an independent variable, which is a factor which is having several categories, with various dependent variable? So if this is the case, what we are trying to look at here is we are trying to look at the ANOVA, and we are trying to look at its various variants, and this is what I would like to concentrate today. So when we talk about doing this analysis, everything else, what we are trying to do is we want to look at, when we concentrate on the univariate or in terms of the bivariate analysis, we are mainly looking at the means of performing these single analysis or uniquely designed multi. We are trying to understand, or we are trying to uniquely design a method wherein we will be able to capture multivariate issues which are there, and that is where in order to understand the underlying construct. If specifically when we are talking about in terms of machine learning, you have got classification based methods wherein all you are trying to do is you are trying to distinguish the groups which are there. You are trying to concentrate upon the variables which is able to distinguish the groups to as maximum extent as possible. So we come across logistic regression, KNN, decision tree, then you have got discriminant analysis, everything else. So when we talk about multivariate analysis techniques, and this becomes more relevant in the research, is why are we considering, or what kind of techniques which are there can be truly said to be multivariate in nature. So if you are mainly looking at it, there are certain questions we will, okay. Regarding the recordings, everything else will be known to you soon. So when we talk about in terms of multivariate techniques which are there, you will be able to notice that you have got several variables, and all these variables are random and interrelated, such that their different effects cannot be meaningfully interpreted separately. And this is where we will be able to say that we are talking about something which is truly multivariate in nature. And thus, when we talk about the purpose of multivariate analytic techniques, is to understand, is to specifically measure, and that is where one has to be able to spend a lot of time. 70% of the work goes into it. So wherein you are doing the literature review, once you have done the literature review, you know what the underlying constructs are, what is the underlying models are, and then you are trying to go and explain, and then you are trying to predict the relationship that exists among the, not the variables. We are specifically referring to what is referred to as variates. Now, when we talk about variates, from now onwards, just remember that when we talk about multivariate analysis, we are looking at some linear combination of several variables together. So if I am looking at if we go back, if you look at the basic statistics, if you are looking at something called as a weighted average, okay, so you have certain variables which are there, you are trying to assign some weightages, and what weighted average value is able to give you is, it is a single value which is able to capture the combinations. It is able to capture the combination of several components. Similarly, when we talk about multivariate, always remember that we are trying to go for a linear combination of several variables, which is referred to as a variate. And what we are trying to do is, we are trying to find out the relationship among these variates. So if I'm talking about factor analysis, what we are trying to do is, we are trying to come up with the various factors, which are in turn are linear combination of several closely related variables. And what we are trying to do is, we are trying to further understand these relationships that exist among these factors using various dependency techniques which are there. So if this is the case, multivariate analysis character lies thus in multiple variates, and not only in number of variables or in terms of the observations that we are considering. So right in the beginning, I want to be very, very clear that when we talk about multivariate nature, what we are referring to here is, we are talking about a variate, and not specifically with respect to the variables. Okay, so since at the end of the day, all we are trying to do is, we have got several variables which are there. These variables has to be, or the percentage of the variation that can be explained using these variables can be minimized or maximized to the extent that what we have to be able to do is, we should be able to reduce these variables into as many variates as possible. And then if we subject that to further analysis, that will be much helpful. So when we talk about mainly in terms of the multivariate analysis, the basic building block, as explained now, is we are mainly talking about in terms of the variates, which are nothing but the linear combinations of several variables. So variables is assigned by us, okay, but in terms of the weights which are there, the weights is decided by the technique that we will be able to use. So if this is the case, when we talk about multiple regression, you will be able to notice that the variate which is there, it tries to, at the end of the day, what we want to do is we want to come up with a variate which is able to determine to the maximum correlation that exists among the various variables which are there. Similarly, when we are talking about in terms of discriminant analysis, or if we are talking about in terms of the classification based methods itself, all we are trying to do is we have a dependent variable which is categorical in nature, and how should we be able to differentiate among these groups to the maximum extent is our concentration. So here also we are mainly looking at it. And similarly, when we talk about in terms of the factor analysis, you will be able to notice that here also we are referring to a variate, and the variate here best represents the underlying structure, and which in turn is based upon the intercorrelation. So whichever variables are highly correlated with each other, then they will be considered together as one of the factor, and then from one factor to another factor, you will be able to notice that there exists a lot of distinction between these factors, but this will be helpful further in various other multivariate analytic techniques also, which will be able to, there are a lot of problems which are associated with respect to, for example, multicollinearity problems, everything else, that we will be able to address when we go for the factor analysis. So when we talk about any sort of analysis, okay, so before we jump into any multivariate analytic techniques, one should be able to be very clear with respect to the measurement scales. So when we collect the data, when we structure the data into rows and columns, you will be able to notice that these columns which are there are always referred to as the features, and you have got the observations which are there across the rows. These are referred to as in terms of the records. So what we want to look at is when we talk about a column, you will be able to notice that these columns which are there are features, and each column represents something. Okay, so when I'm talking about gender, you will be able to notice that it has got only the values which are male, female, or if you have converted that into dummy variables, you have got 1 as well as in terms of 0, which shows the presence or absence of a specific variable. So when we talk about in terms of the measurement scales, you will be able to notice that you have got either the qualitative data, wherein it can be nominal data. So whenever we talk about, and I'll be addressing this issue a lot when we jump through various analysis using SPSS or everything else. So when we look at nominal based data, all we have is we have a feature or we have a column, wherein if I'm looking at gender, all I have is male as well as in terms of female. All I want to understand is how many were present, how many male were there, how many female were there, how many, when I collected the responses in the questionnaire, how many were male, how many were female, and all I want to understand is the frequency. So the presence of a characteristic or an absence of a characteristic, here you will be able to notice that we will be going for a nominal data. When we go for in terms of an ordinal data, this is also a qualitative variable or a discrete variable where we are trying to rank. Okay, so when I say strongly agree to strongly disagree, can you give the responses on strong or satisfied, not satisfied to satisfied? Here you will be able to notice that the responses which will be there, either they will give satisfied or not satisfied, neutral, they will be able to give. But the distance that exists among not satisfied to not satisfied, is it same? Okay, is it same or not? Is not defined. So all we are trying to do is we are trying to rank them, whether this is better or not, satisfied or not satisfied. But you will be able to notice that the distance which is there might not be the same. So when we talk about rank, first rank as well as the second rank and the third rank, when I talk about the first and the second rank and second and the third rank, I may not mean that the marks which is there between first rank and second rank and second rank and third rank is the same. So in these cases, what we'll be doing is we'll be considering these features which are there as an ordinal data. And then we have what is referred to as the quantitative data, wherein we are talking about interval data. In the interval data, all we are saying is, if I take in terms of the same satisfied to not satisfied to satisfied, and if I can say that the distance that exists between them is, for example, from satisfied to not satisfied is 15, okay, or first rank to second rank. If I say that it is equal in nature, so then we will be able to consider this as interval, wherein we say that there is an arbitrary 0 point. So when we talk about Celsius, Fahrenheit, everything else, when we go for ratio, all we are taking is in terms of the metric data, where we are going for collecting, for example, age. We are collecting weight, and we are saying that there exists absolute 0 point, which is there as a reference, and then we are going ahead with the analysis. So if this is the case, you will be able to notice that what we are kind of very used to is Excel. Okay, so we are quite very familiar with respect to Excel, wherein all we are saying is, if I want to look at in terms of a qualitative data, and if I'm looking at a quantitative data, the qualitative data is, consider that you have got some text, and all you are trying to do is you are trying to say the presence or in terms of an absence, wherein you have yes or no, you cannot divide it. Okay, that will be meaningless. So you have got some discrete data which is there. When we are talking about in terms of the quantitative data, you have, for example, age, and if I consider random between, and if I say 34 to 67, this is the age group of the participants who are there in this workshop today. Now what we are referring to here is in terms of the quantitative data. Now when we go for specifically SPSS, okay, so majority of the scholars will be doing their research in SPSS, and I will be explaining this data when we come forward. So here, what we are mainly concentrating upon is at the end, when when you look at in terms of SPSS, you have got data view as well as the variable view. In the data view is where you capture all the data that you have got. Okay, so you'll be keying in all the data, but when it comes to what is these columns, what are these features which are there, in order to designate these features and to indicate whether these features which are there are categorical in nature, are they quantitative or qualitative, you will be able to notice that you have these measures which are there, which says either it is a scale data, or it is an ordinal data, or in terms of a nominal data. So here in SPSS, you will be able to notice that the nominal interval scale as well as the ratio scale has been considered as scale, whereas you have qualitative variables, wherein this has been separately indicated as a nominal data as well as in terms of ordinal data. So how to key in what are these values, everything else, I will be able to explain in another few minutes. So if you are mainly looking at it, you will be able to notice that whenever we go for capturing something, you will come across a lot of errors. Okay, so what you have observed and what you wanted it to be, there might be when I'm keying something in Excel, for example, if I'm keying something in Excel and there are a lot of data entry errors which often we come across, you will be able to notice that there are a lot of measurement errors which are there. And what we are mainly, when we talk about multivariate techniques, what we are mainly concentrating upon is, I have some observed values. When I look at true values, is there significant differences among these? Okay, so if there exist significant differences, that might lead to what is referred to as the measurement error. And what we are trying to do in research is, we are trying to come up with various tools as well as in terms of techniques in order to ensure that we try to address these issues at an earlier stage, as early as possible. And thus, we will be able to look at what is referred to as validity. When we talk about in terms of the validity, all we are trying to say is, I wanted to capture something. Is it really captured or not? And if the measurement which is there is truly worth, okay, has it been observed clearly, so that the differences or the errors which is there is as minimal as possible. So we will be mainly looking at validity as well as in terms of the reliability methods. And when we look at the multivariate measurements, when I talk about variates, okay, which is nothing but in terms of the linear combinations also. Similarly, in research, all we are trying to concentrate at this point of time, or in research, is we are trying to say that I want to understand the expectations. I want to understand whether one is satisfied with the services which is given to the customers who come. So if that is the case, what we are trying to do is, I have got, in order to capture satisfaction, I might have come up with several variables. Okay, so if I am capturing just in terms of satisfaction, all I want to do is, I want to come up with a variate. I want to come up with a weighted average of these several variables and try to capture it. And thus, we will be able to notice that in the multivariate measurements, we are mainly concentrating upon summated scales, which is able to address this issue. And thus, when we talk about in terms of the principle, all we are trying to do is, multiple responses reflect the true response more accurately than does a single response. And this is what we are trying to address even in terms of research. When one goes for capturing, when one goes for questionnaire also, why is that? When we have an underlying construct, in order to capture this underlying construct, all we are trying to do is, we are trying to not only just ask just a direct question, tell me, are you satisfied or not? Okay, so instead of that, what we are trying to do is, we are trying to address this issue by asking several questions. But yeah, ultimately what we want to do is, we want to be able to capture the underlying construct, or in terms of this abstract concept that we have derived from the literature. So if this is the case, whenever we talk about the multivariate analytic techniques, what we are mainly concentrating upon is the statistical significance as well as the statistical power, because at the end of the day, this is where majority of them will be able to do a lot of modifications. Because at the end of the day, all we want to do is, we want to reject the assumption that we have, reject the null hypothesis, and they want to accept the alternative hypothesis. And many of them believe that this, if it doesn't happen, probably the guide will not be able to allow it, or they have to go for collection of the data once again. So what they try to do is, they try to make changes to this alpha as well as the alpha levels, as well as the since we know that there exists the inverse relationship between the type 1 errors with respect to type 2 error, or alpha and beta. And when we are addressing something called as a statistical power, we know that when we talk about this type 1 error which is there, as you go on increasing the beta value, the type 1 error will be almost going to negligible levels. So if it goes to negligible levels, then the statistical power also will be very, very less. So what we want to address here is, we want to address specifically with respect to these aspects, wherein all we are trying to concentrate upon is, if it is on, if no one is on mute, can one of you tell me in terms of the, when we talk about in terms of type 1 error, all we are trying to do is what? Though I know that we have got just 2 hours to complete all these aspects, everything else. When we talk about in terms of type 1 error, you will be able to, you will be able to notice that all we are trying to do here is, we are trying to reject the null hypothesis when it is true. And what we are trying to do here is we are trying to address this issue. And this is where what we are mainly looking at is, this is where the researchers, what they would like to do is they would like to increase the alpha level from 0.01 to 0.05 to 0.10 in order to ensure that even if you have accepted the null hypothesis, by increasing the alpha level, you want to reject the null hypothesis. So by doing so, what we want to, the perception that we have is, ultimately what we want to prove is we want to reject the null hypothesis. But in this case, we will be doing that mistake of type 1 error, which has got lot of ramifications later, and that is directly related with in terms of the power of the test also. And for that reason, what we tend to always look at is, we will be able to look at the impact of the statistical power which is there on the effect size, on the alpha, as well as in terms of the sample size. So as it is quite evident that specifically when we are going for multivariate analytic techniques or in terms of research, all we say is increase the sample size so that these measurement errors which are there are as minimal as possible. And when we are looking specifically in terms of the power analysis, when we are taking in terms of the various combinations, when we say alpha as well as beta, and when we are looking mainly in terms of the effect size as well as in terms of the sample size, what will be the significance values? Okay, so that is mainly in terms of the power analysis which is there. So if we are looking at it, you will be able to notice that when we talk about classification of the multivariate analytic techniques, at the end of the day, we should be mainly concentrating on these three aspects. Okay, so ultimately, when we are talking about business analytic techniques, it is more or less you will be able to understand that the same methodology that was part of the research which is there, if it can be done using the real-time data, huge data, which was not previously possible. Now, what we are trying to address is multivariate analysis techniques. So when we talk about multivariate techniques, all we are trying to address is these three issues. Can the variable be divided into dependent as well as independent classification? So is there any dependence technique that you can see from the literature which is there? So can you identify the variables that you have captured as dependent as well as independent? So do you find that there exists some dependency among these variables which are there? So we can say that if there exists dependence technique, or they are interdependency techniques which are there, that means all we are trying to do is, we do not know what is dependent, we do not know what is independent. So in business analytics, when we talk about artificial intelligence, everything else, all we are trying to do is, in the research, all we are saying is there exists dependence technique. This is referred to as in terms of a supervised learning methods, where we know there are certain variables and these variables are able to capture the dependency or be able to explain the dependent variables which are there. And we have got unsupervised learning methods which are there, where we are saying that there exists no dependency techniques, and thus we are all trying to take in all the variables which are there and then go for either the factors or in terms of the clusters. So these are nothing but the unsupervised learning methods or unsupervised techniques. So if yes, how many variables are treated as Y in a single analysis? So at the point of time, if majority of the time, 80% of the time, what we have mainly looked at is, we take just, if there exists dependence technique, we take one dependent variable, which is either metric or non-metric in nature. If it is metric, we refer to this as regression-based methods. If it is non-metric in nature, or categorical in nature, or discrete in nature, we refer to this as classification based methods. And then we have got, depending upon the dependent variable, what we have understood so far is we will be able to use just one variable for as a dependent variable. What if I can capture, or what if I want to know the dependency techniques which exist between the independent as well as dependent variables, but not at a individual level, but at various combinations. So I have got two dependent variables, I have got three dependent variables, and I want to look at the relationship that exists between these dependent variables with the independent variables. So if that is the case, all I'm trying to address here is I'm going for in terms of ANOVA, ANCOVA, MANOVA. Okay, so we are looking at the various combinations which are there, or canonical correlations which are there. So if this is the case, the third question which has to be asked is, how are Y as well as X both measured, whether they are nominal in nature, whether they are discrete, or whether they are metric in nature. So depending upon which, we will be able to say what kind of method will be used. So if this is the case, you will be able to notice here that when we talk about multivariate analytic techniques, we mainly classify majority of the techniques based upon whether there exists a relationship which is dependency based, or whether we cannot find out the dependency, there exists interdependence among these variables. So if this is the case, you will be able to notice that depending upon what type of relationship are we trying to examine, whether it is a dependence or in terms of interdependence, we will be able to go for various methods as well as in terms of techniques. And specifically for those of you who want to understand more about these techniques which are there. Okay, so what I'm trying to mainly look at is, this is the best book that I have found on multivariate data analysis by Hare, Black, Babin. Okay, so wherein they try to address the multivariate issues which are there in a larger depth, and all I'm trying to do is I'm trying to just summarize all these aspects which are there in as shorter period as possible today. Okay, so if this is the case, when we talk about specifically on a dependence technique, all we are trying to, or all we are used to is when we have just one dependent variable which is metric in nature, and we have got other independent variables. If it is metric in nature, you will be able to notice if there is one independent variable, you go for a simple linear regression. Now, if we go for multiple regression, there might be a possibility that the independent variable which is there can be metric in nature, or it can be categorical also, wherein we use a dummy variable. So in order to ensure the presence or to indicate the presence or absence of a variable, we can also use in terms of the dummy variables, and then we are trying to analyze it. So if this is the case, when we are mainly looking at dependency technique, the first question that we are looking at is how many variables are being predicted. And if I go on the right hand side, you will be able to notice this is what we are mostly familiar with, wherein I'm looking at one dependent variable in a relationship. Okay, and what is the measurement or scale of the dependent variable if it is metric in nature? This in specifically in terms of the various methods that we are using. You will be able to notice that this is where we talk about in terms of a supervised learning methods. Within supervised learning methods, we have got regression based methods, we have got classification based methods. So when we are looking at what is the measurement scale of the dependent variable, if it is found to be metric in nature, you will be going for simple regression, multiple regression. And if you want to understand the dependency that exists between multiple dependent variables with the various independent variables, we will be going for canonical correlations, everything else. And then you have got the conjoint analysis also. And when we are looking at the non-metric data, so if the dependent variable which is there is categorical in nature, we will be able to use various classification based methods. So when we go for classification based methods, you have got logistic regression, you have got discriminant analysis, you go for if we are looking at support vector machines, KNN method, decision tree. So when we are looking, when I'm concentrating here, you will be able to notice that all I'm trying to do is I'm trying to come up with a method which is able to distinguish the groups which are there, because the dependent variable is categorical in nature. So if that is the case, the most often the analysis which is addressed is the discriminant analysis. And why is that? You will be able to know as we proceed further. So discriminant analysis, and then when we move towards the left hand side, okay, in the center, when we have got several dependent variables in a single relationship. Now we are trying to address not only one dependent variable, we are trying to say there might be several dependent variables in our analysis. So if there are several dependent variables in a single relationship, what is the measurement scale of this dependent variable? Now, if it is going to be metric in nature, what is the measurement scale of the predictor variables or predictor variables, which are referred to as the independent variables? So if the dependent variables, it is not a variable, it is several dependent variables, is metric in nature, and then your predictor variable turns out to be metric in nature, we will be going for canonical correlation analysis. All we are trying to do is we are trying to understand the various relationship that exists between independent as well as the dependent variables at various levels. Okay, so all I'm trying to do is, instead of doing one simple linear regression, all I'm trying to look at is I'm trying to look at various combinations of relationship that exist among various dependent variables that I have considered, as well as various independent variables that I have considered. But here I'm assuming that the predictor variables or independent variables are metric in nature. If they are non-metric in nature, this is where we will be concentrating on ANOVA and its various variants which are there, which might be ANOVA, ANCOVA, you have got MANOVA, MANCOVA. Okay, so now then you have got what is the measurement scale of the dependent variable, and if the dependent variables which are there are non-metric in nature, then we will be mainly looking at the canonical correlation analysis. But here we are just saying that we are trying to indicate the presence or absence of the variables which is discrete in nature, using the dummy variables and going for the analysis. Now, what if I have got multiple relationships of dependent as well as in terms of the independent variables? And this is where majority of the research or majority of the papers which have been written mainly concentrate upon in terms of the structure equation modeling. So when you have got multiple relationships among the dependent as well as independent variables, we will be mainly concentrating upon the SEM models or structural equation modeling, and this mainly concentrates upon the first question, which is nothing but, are you considering that there exists some dependency between the variables that you have considered? And this is, where are you deriving this, is mainly through the literature review. And then when we mainly talk about the interdependence techniques which are there, so when I'm talking about the multivariate dependence methods which are there, now you will be able to notice here that whenever we talk about multivariate analysis, we are always using the word variate, which refers to the linear combination of several variables. So when we are looking at the canonical correlation, so wherein we are concentrating upon, there are multiple dependent variables and there are multiple independent variables, and if they are found to be metric in nature, you will be able to notice that all we are trying to go about is canonical correlation. If the variables which are there, the independent variables which are there, are found to be non-metric in nature, we will be going for canonical correlation with the dummy variables. Then if you find that there are multiple dependent variables which are there and the independent variables which are there, which these independent variables, specifically when it comes to ANOVA and its variant, are always referred to as the factors also. So if they are non-metric in nature, this you will be able to notice this is also the kind of combination that we are looking at. So when it comes to These are in terms of the simple methods wherein we move from analysis of variance to multivariate analysis of variance, wherein we take into consideration one dependent variable which is metric in nature and several independent variables which are non-metric in nature, which have got several levels which are there. And if we are moving towards an analysis wherein I would like to do the same analysis of variance not only with one dependent variable, but with several dependent variable, I'll be moving towards multivariate analysis of variance. Now, when I come with the classification based methods where I know that there exist dependence techniques, but if the variable that I have considered, so is non-metric in nature. So if that is the case, for example, where success or failure, there are specifically in terms of business analytics, you have got benign when the cells which are there are cancerous or not, benign or malignant. So you have got certain variables which are non-metric in nature, and you are trying to understand the distinction that exists among these groups. So if this is the case, you have got the independent variables which are metric in nature and the dependent variable which is there, and we are trying to mainly look at in terms of the discriminant analysis, but there are various other methods also. And here, when it comes to the multiple regression based methods, all we are saying is the dependent variable is metric in nature. When we concentrate upon classification based methods, the dependent variable which is there is discrete or categorical in nature. And when we come across in terms of the conjoint analysis, you will be able to notice that you have got the dependent variable, but the independent variable which is there and the dependent variable, if they are non-metric in nature, we will be going for conjoint analysis. And if we are looking at various combinations, several combinations between the dependent variable as well as in terms of the independent variables, then we will be mainly looking for in terms of the structural equation modeling. Now, when we look at, when we go for the first question and then we ask the question, is there any dependence technique or not? And if I am not able to understand the dependency between the variables or the variables in the beginning, I will be going for something called as an interdependence technique. So if this is the case, all we are trying to do is, if I am trying to consider, so if I can show the same thing in Excel, if I am trying to say that these are the various features which are there. So if I can consider the feature, for example, A, B, C, D, I have considered various variables which are there. So if these are the various features which are there, and if I cannot understand the dependence technique among these variables which are there, so then what I can do is I can come up with a linear combination of these variables in such a way that they can be combined together into factors, and each factor is able to explain maximum percentage of the variation that exists among the variables. So if that is the case, if I am going column wise, which is nothing but if I am looking at the features and then I'm trying to decide to go for dimension reduction or reduction in the number of variables which are there, you will be able to notice that you go for the factor analysis techniques, EFA as well as in terms of CFA. Now, if you are looking mainly in terms of the cases or in terms of the respondents, so I want to be able to analyze the data, but the analysis need not be done column wise, which is nothing but the feature wise data. I don't want to do it. But what if I find that the cases which are there, the records which are there, there might be a relationship among these cases or in terms of the record. So if I am trying to say the data which has been collected among the various respondents, they can be grouped together first. So I will be able to mainly go for in terms of the cluster analysis techniques which are there. So here we, if I am going for the structure of relationship among the cases or in terms of the respondents, I am mainly looking at the cluster analysis. So if I'm looking among the variables which are there, I'm mainly looking at the factor analysis. And if I am looking at the objects, okay, so if I'm looking at the objects and how are these attributes which are there, or the objects which are there, if they are completely metric in nature, okay, so then I will be going for multi-dimensional scaling methods. Or if I find that they are non-metric in nature, I'll be able to go for correspondence analysis. There has been, this is just in terms of a limited number of techniques which has been given, but you will be able to understand that when we talk about multivariate analysis techniques, all we are mainly concentrating upon is you have to be first able to figure out, and this is where the majority of the research is also headed, is when we collect all the responses using the questionnaire. And what we want to try to find out is we want to try to find out the underlying constructs which are there. So what we directly jump into is we directly jump into factor analysis. We go for assuming that there is a interdependence techniques which are there. I'm not able to find out the dependency right away. So what we are trying to do is we are trying to go for the factor analysis, or in terms of the cluster analysis, is first we are trying to minimize the data to the manageable level, and these are referred to as the supervised learning methods, PCA, principal component analysis. So when we are going for reducing the amount of data, and when we reduce the amount of data, all we are trying to do look at is we are trying to say what percentage of the variation. So I should be able to minimize the data to as much as possible, but I should not be forgetting in terms of the variation or the percentage of the variance which is explained. So if this is the case, in research, what we are trying to concentrate mainly on is we are trying to say first there exists interdependency. I cannot find out the relationship between X as well as Y. I cannot find out at the point. I know there might exist some underlying constructs which are there. So we directly jump into interdependency techniques. Once we have known what are these variables are, once we know what are these factors are, and then we will be able to use these factors, or we will be able to use these clusters into interdependency techniques, and then we will be able to go ahead. And this is how most of the way it is followed. So how to go about understanding in terms of the multivariate analytic techniques is what I strongly believe is we should be very, very clear with respect to univariate as well as the multivariate analysis, and should be very, very clear with respect to the techniques as well as the interpretations of the various outputs that we'll be able to get, and then only we should be able to jump into multivariate analytic techniques. So when we look at multivariate analytic techniques, to as much extent as possible, I will try to cover in terms of principal component, regression based, classification based methods, and if possible in terms of canonical correlation analysis. And today mainly I'll be concentrating on the univariate, bivariate, as well as the ANOVA and its various variations. So you have got conjoint, cluster, perceptual, mapping, everything else. So correspondence analysis. So what we'll try to concentrate upon is though there are various methods, the underlying understanding has to be very, very clear. So if you are clear with respect to why these techniques are really important, when we have these univariate and bivariate analysis, and we can make use of these univariate and bivariate analysis techniques to the maximum extent, why is there a necessity for us to move forward to multivariate analytic techniques is if we have a clear understanding about it, then it becomes very, very clear. So when we talk about at this present point of time, I would now would like to go for univariate as well as in terms of bivariate. If there are any questions up now, you can post the same thing in the chat box, because any questions you have got, if there are any questions which are there, you can post that in the chat box, or otherwise we can move forward, because now it is exactly 10 o'clock. So we'll have another 1 hour which is there. So before I jump into the univariate, bivariate, as well as the ANOVA and its variations, I'd like to see if there are any questions. Any questions? You can post that in the chat box if there are any. Okay, so what we'll do is we will move right into understanding the basic concepts now. Though majority of the participants who have joined here are research scholars, what I truly believe is if you have a clear understanding about this, then it becomes very, very easier when we go ahead. So I'll be spending like just 10 minutes or 15 minutes into these univariate methods which are there, univariate, bivariate methods, and directly would jump into the multivariate techniques which are there. So if that is the case, so please allow me to. Okay. So when we come across mainly in terms of there was one question on can we construct models in multivariate analysis techniques. We'll come to that, and specifically all we are trying to do is when we say we are trying to build in terms of models, first and foremost is we are trying to say that is there any underlying theory or underlying literature which is there which talks about these models. And when we go for multivariate analytic techniques, and when we are talking mainly about variates, which is nothing, when we talk about variates, all we are trying to do is are these variates in any way related with each other or not? So at the end of the day, all we are trying to do is we are trying to come up with various models. Yes, definitely. And this is where most of the SEM as well as in terms of CFA comes into picture. So when we mainly talk about in terms of univariate analytic techniques, what we start is simple things. Okay, so when we talk about one sample t-test, all we are trying to do is we are trying to examine whether the mean of a population which is there is statistically different from that of a known or in terms of the hypothesized value which is there. So what we mean by it is nothing but to give a perspective is if I consider the dependent variable which is there is continuous in nature. For example, I have given the final marks, okay, and if I assume that the at the end of the day I am assuming that the marks which is there of the entire class might be average, might be equal to 80. This has to be null hypothesis has to be equal to 80, and these three are nothing but alternative. So just a correction here. So when we assume that the null hypothesis which is there, if I assume that is equal to 80, and the alternative hypothesis says it might be different, it might be less than or it can be more than. So if that is the case, we are looking at in terms of the two-tailed test as well as in terms of one-tailed test also. So if that is the case, when we when I go back into Excel and just have a look at this simple data also, and I'll be very, very quick enough not to waste all your time also. So when I'm looking at in terms of the final marks, and if I consider that there are 40 students who are there, and if I come up with some random number between, for example, 75 to 85, this is the scores which are there. And then if I copy and so all I'm trying to assume here is the null hypothesis that I'm trying to say is I have got some expectations regarding the class, and I'm just saying that the average value which is there, the average value might be equal to 80, or alternative hypothesis is it might not be. So if I take this data go to SPSS. Okay, so here in the SPSS, you will be able to notice that in the data view, all we try to do is we try to show what these data are and the naming of the data and what kind of data is it, whether it is a qualitative data or a quantitative data will be always assigned in the variable view. So you have the students scores which is there, and in the variable view, all I'm trying to do is I'm trying to say these are nothing but the marks of the students, and all are numerical data which is there. And then these are the marks of the students. And then when I come to the measure, you will be able to notice that this is a quantitative data. So since it is a quantitative data, than 3 usually, right? These used now, yeah. So you have got here in terms of the scale, and once I have it, you will be able to notice that when I go for here compare means and I go for one sample t-test, and all I am trying to do is I'm trying to take the marks. I have got certain assumptions regarding this data, which is the test value is nothing but equals to 80, and I'm trying to say that the alpha level is nothing but 0.05, and then I'm just saying, okay. Now, if I, can you guys see the output? Okay. So here in the output, you will be able to notice that the null hypothesis that I have is H naught is the mean is nothing but equal to 80. And all I am trying to notice here is at the alpha level at 0.05, since this value which is there is greater than 0.05, I'm just trying to accept the null hypothesis, and I'm just trying to say that yes, the null hypothesis is accepted and there is no way, and the marks which is there is almost closer to 80. That is what we are trying to say, and the mean is something like 79.7. So if I am looking at specifically the one sample t-test, you will be able to notice that we are trying to take in terms of a dependent variable, and we are trying to make some assumptions depending upon this variable which is there. Now, when we move across in terms of the two sample t-test, when we go for the two sample t-test, all we are trying to do is now we are coming across two samples. And there is one question which has been asked on t-test as well as in terms of z-test. Come to that. So we have what we are trying to do is we are trying to find whether there exist differences among these two samples. So what we are trying to do is we are trying to take a dependent variable which is there is continuous in nature, and then we are trying to consider an independent variable which is categorical in nature. Now this is where most of the time many of them get confused when they are doing the analysis in Excel as well as when they are doing the analysis in SPSS also. When we go for Excel, you will be able to notice that if I have got for two sample, all I have tried to do here is if I say the final marks which was obtained previously, this was for the entire class, which was 40 students who are there, and I had some assumptions regarding the entire class, and I am trying to prove it. Okay. So when we are taking mainly with respect to two sample t-test, all I'm saying is the students who are there, 20 students, one set of students belong to A section, another set of students belong to B section. So if that is the case, if I say a random between, and the score which is there is between 80 and 90, and here I have got equals to random between, the scores which is there is 75 to 90. Okay. So if I have got these, and if I am trying to say whether there exist significant differences among the means, so all I'm trying to do is I'm trying to take the average across these two sections which are there, and I am trying to say these averages that I am trying to see here, are they significantly different or not? So if this is the case, the null hypothesis that I am trying to prove is the average which is there for A section, is it equal to that of B section or not so? Okay, so if this is the case, if in Excel, what we try to do is, if I go to data, and specifically, if I'm mainly looking at, if I go to options, and in the options, if I go to add-ins, and in the add-ins, Excel add-ins, and here we have got something called as the analysis tool pack, which is there. So all we are trying to do is, we are trying to use the data analysis tool pack, and then we are saying whether there exist significant differences that lies among these two sections which are there. Okay, so when we try to do the same thing in SPSS, all we are trying to do is, if I copy this data which is there, which belongs to section A, and if I copy the data of the another section, so here I'm saying this belongs to section A, and the other 10 values which are there belongs to section B. So here you will be able to notice that the first variable, the dependent variable which is there, is found to be quantitative in nature, or it is found to be metric in nature. Whereas in terms of the independent variable which is there, independent variable is qualitative in nature, or this is also referred to as a factor which has got two levels. Okay, so if I copy this data, if I go back to SPSS, just a minute. Okay, so this is the data that we had. So if I copy this data from Excel, this is the data. So I'll just copy and paste the same thing. Okay, so here, if I have it, you will be able to notice the first one is nothing but the marks, and this is found to be numeric in nature. Okay, quantitative, and this is nothing but the marks of students. You have got here the measure is nothing but this is a scale based variable. When we come across the second one, you will be able to notice that this is designating, this is a factor which is having two levels. So if that is the case, since it is text, it is considered here as a string. Okay, so if I consider this as section, and then you will be able to notice that this is sections, and then this is nominal in nature. But what we try to do is, we try to convert this text data into a dummy variable, which will be able to say the presence of section A can be given as 1, section B as 2, so that it is easier for further analysis. So what we do is, there is something called as a transform. So if we go for transform, recode into either different variables, or so if I go for decode into same variables, I'll take the sections, I'll go for old and new values. Here in the value, I'll type in wherever you come across a text called as section A, give the value as 1. And if you come across the text which is nothing but section B, you have the value as 2. And then if I say okay and okay here, now you will be able to notice that if I go back to the data set, you will be able to notice that this has been converted, whatever text that you had has been converted into numerical values, and that is dummy variables. And when I go for the variable, since it has been converted into number, what you can do is you can convert this into numerical values, and then in the values, what we'll try to do is, for one, here refers to the label that was given was section A, and then the value 2 here is nothing but section B, add, okay, and this is nothing but the nominal data. So if I have got this, now if I go to analyze, if I go for compare means, here what I'm trying to do is I'm trying to take one variable which is there. The dependent variable is metric in nature. The independent variable which is there is categorical or discrete in nature, is a factor with two levels. So if I go for independent sample t-test, the marks is nothing but the test variable. This sections which is there is nothing but the grouping variable, and all I'm trying to say here is this is 1, and the section 2 I have given it as value 2. And then if I say continue, and then here option, same thing, I'm trying to make a decision at alpha level of 0.05, and then if I go for okay, so in the output you will be able to notice that all it tries to say is, the first one is the descriptive statistics, wherein section A has got a mean of 83.6, section B has 84.2, and all we are trying to do is we are trying to say, is there any significant differences in the marks which is scored among the class which is there. And here what we are trying to look at is, we are trying to specifically, when we go for doing the two sample t-test, all we are trying to make an assumption is whether the variances which is there among the two groups, whether it is the same or whether it is different. And in order to know whether there is equality of the variances, we will be able to do the leave-in test also. But up till as of now, what we are trying to do is, if we assume whether the variance is equal or not equal, you will be able to notice that the significance value which is there is greater than 0.05, and thus we will be able to accept the null hypothesis that there exists no significant differences among the means of these two sections that we are mainly talking about. So if this is the case, you will be able to notice that in the two sample t-test, all we have tried to do is, we have a dependent variable which is continuous in nature. We have got independent variable which has got two groups, and here we are mainly talking about in terms of the sections. But when we come across in terms of the three sample t-test, when we talk about three samples, and when we look at mainly in terms of three samples, all we are trying to do is, we are trying to examine whether there exist differences among the mean of two or more populations. So if this is the case, what we are trying to see here is, the independent variables or the factors which are there are categorical, okay, but it has got more than two levels. And when we talk about dependent variable is metric in nature. So if this is the case, all we are saying is the dependent variable is final marks, but the independent variable which is there is not just two groups that we were talking about, is now three groups. So if I take the same thing in Excel and try to find out, you will be able to notice that now I am not talking about just two sections. I'm trying to talk about in terms of three sections which are there. And I'm just trying to say, the null hypothesis that I'm trying to say is, if I consider the average of A section, if I consider the average of B section, and if I consider the average of C section which is there, all I'm trying to assume is, the null hypothesis is the average which is there across all these sections is all same. When I go for in terms of alternative hypothesis, all I'm trying to say is, there might be differences at least among two sections, okay. But the problem here is the difference in the means between average between A section or B section, or it is between A section or in terms of C section, or is it between the B section and the C section? Okay. So what when we look at in terms of the ANOVA, what it is trying to do is it is trying to look at whether there exist significant differences in the marks among these three sections which are there. But in order for us to understand among if there exist significant differences, if we reject the null hypothesis, among which two sections the marks is significantly different. For that, what we tend to do is we will be able to go for post-hoc test, and then we'll try to examine. So if I am doing in Excel, and if I go for data here, if I go for data analysis tool pack, and if I go for one-way ANOVA method which is there, all I need to do is I have to select all these three sections, and if I go for finding out whether there exist significant differences or not, you will be able to notice that it gives you the output. Here, what we are trying to assume is we have got three columns, or in terms of the three features. Okay. But this is, so when we go for, when I take the same data, I'll just copy the same data. This is for the first two sections, and I'll try to have for this third section, like 45 to 78. Now, I would like to find out, is there any significant differences among these? So what I'll do is, I will try to take the data which belongs to section A. Then I'll try to take the data which belong to section B. And this is the data which belongs to section C. So if you notice here, all we have is, now we have a dependent variable which is qualitative in nature or metric in nature, and then we have got an independent variable which is there, is discrete, or it is, this is quantitative in nature, this is qualitative in nature, and this is nothing but it is a factor with more than two levels. So here I have got three levels. Now if I copy this data, if I now go to yes, PSS. So here all I am trying to look at is, so if I copy the data, okay. So here I have got, once again, because doing once again is always better, so that there will be more understanding. So if I take the marks of the student, and this is nothing but the scale based data, which is a metric data. When I come for the second, this is nothing but it is a categorical in nature. It is a factor with more than two levels. So if I take, this is nothing but the section, and this is a string section. This is nothing but the nominal data. But what we would like to do is we would like to convert this into dummy variables. So if I go to transform, recode into different variable, I'll take it as a different variable. So now if I take section, and if I say this as the name that I will be able to give is section refined change and old and new values. So wherever I have got section A, I'll convert this to value 1. Wherever I have got section B, I'll be able to convert this to 2, where I have got section C. Then continue, and then if I say OK, now you will be able to notice that I have got these section A, section B has been now converted into dummy variables. All I am trying to show is the presence of section A is given by one value. So when I now go for the variable view, you will be able to notice that it is a numeric value. And in the values here, I'll be able to say 1 here refers to section A, 2 here refers to section B, and 3 here refers to section C. Okay. And this is nothing but in terms of the nominal data. And now what we are trying to do is we are going to analyze, we are going to compare means, and what we are trying to do is here in the independent sample t-test, if I find that if I'm taking a data which is before and after data, we'll be able to go for paired sample t-test. Now here, since I want to test whether there is significant differences among the 3 groups that I have considered, the dependent variable is metric in nature, the independent variable is categorical in nature. So if I go for one-way ANOVA, this is nothing but the marks. The section refined is nothing but it is a factor with more than 2 levels. If I go for the post-hoc test, if I'm mainly looking at in terms of equal variances, we'll just go for Tukey test. And then the options, I'll take descriptives. If you want means plot, because it will be helpful when we analyze in terms of ANCOVA, MANOVA, everything else. And then if I say OK, so now if I look at the results which are there, okay, so here first and foremost what we are looking at is we are looking at the 3 sections, and then we will be able to identify here that the means of the section A as well as section B are closer, but we do find that there exist some differences between the performance of section C with respect to that of B as well as A. And then if you want to prove that statistically, we will be going for the ANOVA test, wherein if you are looking for the F value as well as the significance value, here, since the value is less than 0.05, we will be able to say that we reject the null hypothesis and accept the alternative hypothesis that there exist differences among these 3 sections which are there. Now, if I find that there exist significant differences among these 3 sections, what is very, very important here is among which of these groups the differences lies. So if I'm going for the post-hoc test, you will be able to notice that you have got section A, I'm comparing that with section B, and then finding out, is there any significant differences between section A and section B? And according to the significance value, we can notice here that it is less than 0.05, greater than 0.05. So here you will be able to notice that next one, you have got section A with section C, and the significance value which is there is less than 0.05. That means if I had done this as a 2 sample t-test, I would have done 3 times. I would have done the 2 sample t-test 3 times. But in terms of ANOVA, I know that there exist statistical differences among these 3 groups, but among which 2 groups the significant differences lies, that I will be able to come to know using the post-hoc test which is there. And here it is very, very clear that there exist significant differences between section A as well as in terms of section C. So if I mainly look at in terms of ANOVA, all I am trying to do is I am trying to take in terms of a dependent variable which is continuous in nature, and the independent variable which has got more than 2 levels, and it is categorical in nature. So if that is the case, when we look at in terms of MVA ANOVA, if I say all I have tried to look at so far, is I have got just one independent variable which had got several levels which were there. But what if I can come up with two or more factors? So if there are two or more factors which is involved, and if there is more than one independent variable, then I will be going for what is called as the n-way ANOVA, where if I am talking about in terms of two-way ANOVA, all I am trying to say is there are two categorical independent variables which are involved, and I am trying to try to find out in terms of is there any significant differences among various combinations which are there. So I'm looking at one category, one independent variable which has got certain sections or categories. Among that, say I will take another independent variable. I'll try to look at these combinations and then compare that with the dependent variable which is there. Similarly, if it is in terms of three-way ANOVA, we are trying to go for three categorical independent variables which are involved, and the dependent variable which is there is metric in nature. So if that is the case, when we are looking at the two-way ANOVA, for this, what I will be doing is I will be using a ready-made data which is there. So if I go to the data, which now here is a data wherein what it is, what it talks about is it talks about the revenue which is earned by the sales representatives, okay, across the various time period. So you might be able to consider this more or less like a, okay, so here you have got certain features which are there, gender. So this I'll try to show it in Excel. That would be much better. Just a minute. Okay, so here consider that this is the data that I have considered for SPSS also. So if I consider this entire data which is there, and if I go to home, if I go to sort and filter, you will be able to notice the gender is also a categorical data, okay, which has got two levels, male and female. When it comes to regions, it has got three levels. Then you have got the product. Now the product has got in terms of 6 products. We are talking about 6 products. You have colors, which are 5 colors in nature. Then you have got units as well as the revenue. So if I can consider this data for the analysis, you have got certain data or certain variables which are there. These are metric data. And these are the various variables which are there, which are categorical in nature. So if I want to use this data, if I have transferred this data into SPSS, okay, so in SPSS, you will be able to notice that you have got gender, region, product, color, units, as well as in terms of the revenues. And what I have tried to do is here, the gender which is there is a categorical variable with 2 levels. Then region is with 3 levels. Then similarly, the product which is there has got 6 categories. Then you have got the color which is having 5 categories, and the units as well as the revenue which is there are nothing but the scale-based data. So this is the data that we have. Now, if I go back and have a look at the method that we are talking about, is nothing but if I want to come up with the two-way ANOVA. So if I want to come up with two-way ANOVA, wherein the dependent variable is found to be continuous in nature, but now the distinction that exists is in terms of the number of variables that I will be considering as a independent variable. So if I come to the independent variable which is there, first one, independent variable, if we had considered 3 groups, and if we had considered this as sections only. The another independent variable, I can consider it as 2 groups, which is nothing but the gender. So all I want to find out is there any significant differences that lies in the final marks which is scored, not only among in terms of the 3 groups or 3 sections which is there, but also among the gender. So I be able to look into all these combinations which are there. So if that is the case, we will be able to mainly go about with what is called as the two-way ANOVA. So when we come across, so here, if I consider revenue as a dependent variable, so for this analysis, if I consider revenue as the dependent variable, which is metric in nature, and if I consider the gender as well as in terms of the region, so region has got 3 levels, it is a factor with 3 levels, the gender is a factor with 2 levels. If I can consider it, so what I'll do is, I'll go to analyze, I'll go to compare means. So far, what we had done is, we had looked up till this one-way ANOVA. So what we were mainly talking about is, we were looking at the methods, okay, but we were not discussing about the multivariate nature of the variables which were there. So if I want to go for it, I'll be going for general linear model. I'll go to univariate. In the univariate, I'll be considering the dependent variable is nothing but the revenue which is earned. When it comes to the various factors, since I'm using more than one independent variable, and here in this case, the independent variable is categorical in nature, I'll take the region which is there as well as the gender. And then if I want to see in terms of the plots, I can take a region, gender, I can add. Then let me get this as line charts itself. Then you have got post-hoc test. I can take region, Yuki. EM means I can consider one Firani, or I can consider considering in terms of various interactions which are there. So continue. I'll go for save. Options, I can consider the descriptive statistics, and then okay. So if I look at the output which is there, you will be able to notice what I want to understand here is, I want to understand that if I had gone for one-way ANOVA, okay, if I had gone for one-way ANOVA, I would have taken one dependent variable, one independent variable. Now I'm going for two independent variables. So I should be able to look at the categorization among these variables with respect to a dependent variable. So if I go and have a look at the output, you will be able to now notice that when it comes to descriptive statistics, what the descriptive statistics clearly indicates here is, it is considering the region, it is considering the gender. So it is considering both the independent variables, which is categorical in nature. So if I take East region and if I take male, what is the mean which is there? So all I'm trying to now do is, you can now see that I am trying to do several univariate analytic techniques, or several univariate analytic techniques into one technique, and thus the multivariate characteristic comes into picture, wherein I'm trying to look at each and every combination of the two independent variables with respect to a dependent variable which is metric in nature. Just a minute. So here, if this is the case, what we are trying to do is, we are trying to analyze that region, whether there is, if I had done one-way ANOVA, and if I had tested whether the revenue which is earned is significantly different among the regions, you will be able to notice that there exists significant differences if a region is considered. When I take in terms of the gender, you will be able to notice that there exists not much significant differences. But what I'm mainly interested in is, I'm interested mainly in the interaction effects which is there, region with gender, and then in terms of the revenue which is earned. So as we go for multivariate analysis techniques, you will be able to notice that the intervention effects which are there come into place, and we should be able to address these issues as much as possible. And then only we should be able to go ahead with respect to analysis. So here all we are trying to do is we are trying to understand the relationship that exists among these methods, and specifically when it comes to the post hoc test also, you will be able to notice that all we are trying to do is if there exist significant differences among which regions, if I take region as well as in terms of the gender, which one. So I should be able to do separately gender as well as the region, and then find out whether there exists significant effect or not. And specifically when it comes to the profile plots, you will be able to notice that if there exists no significant differences, no interaction effects, then these should be parallel in nature. Since they are coinciding, you will be able to notice that the plots are crossing with each other. Then we will be definitely be able to say that there might exist, okay, there might exist some significant interaction effects between the gender region as well as in terms of the revenue earned. So when we are mainly talking about the one-way ANOVA or two-way ANOVA, we are talking about a dependent variable with several with two independent variables. If I go for three-way ANOVA, you will have three independent variables. Now, if this is the case, when we move to ANCOVA, so okay, so when we move from ANOVA to ANCOVA, why there is a need? You will be able to notice that if the set of independent variables which are there are found to be both categorical as well as metric in nature. So if they are found to be categorical as well as metric in nature, whichever independent variable which is metric in nature is in turn referred to as a covariate. So far what you were kind of used to is you had one dependent variable and you had got several independent variables, and these were all categorical in nature. But if I look at in terms of ANCOVA, you will be able to notice that you come across a situation wherein the independent variable which is there is now found not only to be categorical in nature, it is also metric in nature. So if this is the case, when I look at ANCOVA, what I am looking at is I have a dependent variable which is continuous. I have got an independent variable which is categorical in nature. It has got three sections, but I am considering another independent variable which is there, which is nothing but the quiz marks. So, and I am trying to find this relationship. Why is this referred to as a ANCOVA? Is for the reason that if I had taken a dependent variable which is continuous, independent variable which is categorical, if I had run through this is nothing but one-way ANOVA. If I take dependent variable which is continuous, which is full marks, and if I take independent variable which is quiz marks, and then if I do the analysis, you will be able to notice this is nothing but is your simple linear regression. So all we are trying to do is we are trying to use a method which has got both ANOVA as well as in terms of the regression method. So if I consider both these, this is nothing but in terms of ANCOVA. So if I am looking at, if I go back, have a look at the demo data. Now here, if I consider one variable region, well, if I consider this as an independent variable, and if I consider the units which is there, okay, the units which is sold, and this I will be able to consider it as a metric data. So if that is the case, if I go to analyze, if I go to general linear model, you will now be able to notice that if I go for the univariate, you have something called as a covariates. Okay, this is nothing but it is a metric data. So if I remove the gender, if I take the units which is sold, take it as a covariate, then lots, I'll take it as lots. The EM means, okay, since I'm taking just one, okay, there is no requirement for interaction effects here. Then options, descriptive statistics, I can look at the effect size. Okay. Now here you will be able to notice that I have taken one independent variable which is categorical in nature, one independent variable which is metric in nature, and then I'm trying to find out whether there exist significant differences in the revenue which is earned. So if this is the case, all we are trying to do is I'm trying to say the descriptive statistics which is there is with respect to region as well as in terms of the revenue earned, and then the results clearly point out with respect to revenue earned with the units as well as in terms of the region. And all I'm trying to do is I'm trying to find out, is there any significant impact of the independent variables on the dependent variable or not? So this is where we will be able to go for what is referred to as a ANCOA method. And I'm not trying to go much in depth because we all know that there is limitations of time. But what I want to clearly showcase here is why these methods are used, and how it will be much helpful in your research when you have identified the variables and you want to come up with various models. Okay, so when we come across MANOVA as well as in terms of variations, you will be able to notice we went for ANOVA. Then we understood that there might be possibility that the independent variables which are there might not be categorical in nature. They might be metric also in nature. So we moved towards what is called as the ANCOVA, and then we come for what is referred to as a MANOVA, wherein here is where you will be able to notice that in the one-way ANOVA, what we are trying to do is we are trying to say that these used to determine whether there exist any differences between independent groups of more than one continuous dependent variable. So we are kind of used to doing the analysis, taking into consideration just one dependent variable and trying to do the analysis. Okay, so what if you come across an analysis where you are subjected to more than one dependent variable, and how would you go about? For these, we always refer to this as MANOVA. So in this regard, it differs from the one-way ANOVA in the case that you have got a independent variable, which we have taken it as categorical, which we know that. But here, the dependent variable which is there, we will not only be considering just one dependent variable, we will now be considering two dependent variables. So since we are considering two dependent variable, one is you have got final marks, you have got in terms of the placement salary, and all you are trying to do is you are trying to consider it across in terms of the gender. So all I am trying to do is I'm trying to do one-way ANOVA. Instead of doing one-way ANOVA twice, I'm trying to look at the interaction effects which exist between independent variable with the dependent variable, also taking into consideration the various possible combinations that might exist among these dependent variables also. So this is always referred to as in terms of MANOVA. And here is where you will be able to notice the multivariate nature of the techniques is quite evident, and thus when we go for testing the null hypothesis, you will be able to notice in the t-test as well as ANOVA, what we have concentrated upon is equality of the single dependent variable means across the various groups, across the various levels of the factors that we had considered. In the multivariate techniques, what we are trying to do is we are trying to examine the equality of the vectors of means on multiple dependent variables across in terms of the various groups. And thus the unique aspect of MANOVA is variate optimally combines the multiple dependent measures into a single value that maximizes differences across the groups. And but only difference you will be able to notice that in the MANOVA, all we are trying to do is we are trying to take the categories and then trying to say, is it able to maximize the differences among the groups? But here the variable that we are talking about is independent variable. If I do exact reverse of it, this is nothing but classification based methods where we are talking about the independent variables. If they are optimally combined together, is there any possibility to maximize the differences among the groups which are part of the dependent variable becomes part of the classification based methods. But here we are talking about mainly in terms of the independent variable, and this is where one-way MANOVA comes into picture. And then if I extend the same thing in terms of the two-way MANOVA, all we are trying independent variables, but now you have two independent variables which are there, and these two independent variables are categorical in nature. So now if I want to read through in terms of the, as we have noticed also here, that when I showed you variate optimally combines the multiple dependent measures into a single value that maximizes differences across the groups with respect to one factor. But if I do consider among two factors, you will have what is referred to as the two-way MANOVA. And thus, when we go for so when we look at specifically the SPSS, when we go to analyze general linear model, since the true nature of multivariate techniques come into picture, you will be going for what is called as the multivariate. So in the generalized or general linear model, you will be coming across multivariate methods. So in the multivariate methods, if I use, for example, these are the two metric data which is there, dependent variables, revenues earned as well as the units sold. And if I consider the region as well as in terms of the gender being in terms of the fixed factor. So if I consider just one independent variable, this becomes one-way MANOVA. If I consider two independent variables, this becomes two-way MANOVA. And then if I go for the same kind of analysis where I'm looking at the plots, if I'm looking at the post hoc test which exist, and if I'm mainly looking at the EM means, if I want to look at if there exist any interactions among these, and then options, descriptive statistics. And then if I go for OK, you will be now able to notice that what we are trying to do is we are trying to come up with one-way MANOVA as well as in terms of two-way MANOVA. And if we go for the further methods, depending upon what, how many dependent variable as well as in terms of the independent variables will be part of the analysis, you will be able to notice that when we talk about MANCOVA, here we will have more than one dependent variable which is there, and independent variables which is there can be more than one. But what we are mainly concentrating here is we are trying to take the covariance, because since we are considering the independent variables also, we are trying to try to consider in terms of the covariance values or the variance covariance metrics which is there among the various dependent variables, and then trying to find out is it same or different. If you are trying to make a corrections with respect to it, we will be able to go for MANCOVA as well as in terms of ANCOVA also. So this is what I wanted to do today is I just wanted to explain in terms of when we want to go ahead with multivariate analytic techniques or understand the multivariate nature. What we do is we always try to look at in terms of the univariate nature of the analysis, and then we will be able to consider make it more complex by including more and more independent variables or dependent variables, and depending upon what kind of categories that we are trying to consider, is it a quantitative or in terms of the qualitative variables, we will be moving from the t-test to sample ANOVA to in terms of ANCOVA, MANOVA, MANCOVA, ANCOVA, and all the rest other methods. Okay, so this is what I just wanted to complete in today's session. So we have got another 5 minutes. If you guys have any questions, please do ask. And there was definitely one question on the t-test. Okay, so what we always believe is when the sample size is less than 30. Okay, so we are going for the t-test, and if the sample size is more than 30, we know that the t-test will be able to follow the normal distribution, and then thus we will be able to go for. So you will be able to notice that there is no compulsion that if you have sample more than 30, okay, even if you do t-test also,